Alright, now let's look at example number 6. A box of mass 20 kg is on a rough horizontal plane. The box is pulled by a force which is applied at an angle of 30 degrees here. If the coefficient of static friction between the box and the plane is 0.3 and the box moves at constant speed, calculate the N and then the applied force and then the static friction force. Okay, now let's extract the information because it's not that clear based on the question. So we have M equal to 20 kilogram, and then we have the coefficient of static friction to be mu s to be 0.3, and then the box moves at constant speed, meaning the acceleration is equal to 0. Okay, now let's draw the free body diagram. So we have a dot to represent the object, and then now we have to draw the forces. So there's weight, and then there's F, and then this is a rough horizontal plane, so there's gonna be frictional force, and then there is a normal force. What else? Tension jateda sabab there's no rope. Okay, so that is the forces that are present. So this is mg, this is force, this is the normal force, this is the static frictional force. Okay, Fs dia bagi kita static friction kan, right? And then let's draw the axis, nanti bingung. Okay, so this is 30 degree. Okay, so what else are we missing? Acceleration is 0, so we are back to the convention of up and right is positive, left and below is negative. Okay, so let's do this. We are gonna look at the first component first, which is the x component equal to 0. Okay, so F cos 30 degree minus Fs, is that all? Yes, this is the only horizontal component, so this is equal to 0. Okay, or you can equal to 0 dulu, and then you can write F cos 30 degree minus mu s n equal to 0, and this one you can let to be equal to equation 1. Okay, and then now you have to look at the y component, Fy equal to 0. So n plus F sine 30 degree minus mg equal to 0. So this is the only vertical component na F punada. Okay, now we have to find the normal reaction force. So we don't have the value of F, so we can let this F to be equal so that we can remove this F lah. Okay, so I can use this equation lah. So F is equal to mu Sn over cos 30. Equation 1, this is equation 2. So we can substitute 1 into 2. So n equal plus F, which is mu Sn over cos 30 degree sine 30 degree minus mg equal to 0. Okay, and then what else do we have? So this one sekarang semua ada kan? So M ada, G adalah obviously, N is the one that we are looking for. So just rearrange and then you'll get the normal reaction force to be equal to 167 Newton. Okay, so make sure kamu rearrange ni. make sure kamu rearrange betul-betul lah. Ada N di sini, ada N di sini, okay? So if you are wrong, then it's not your physics yang wrong, it's your maths. Okay, so make sure your maths are correct so that you get the correct answer lah. Okay, and then next is the applied force. So now we have to find the applied force. We can just substitute N into equation 1 to get the value of force, in which you will get 57.9 Newton. Okay, and then lastly we have to find the static friction, in which static friction can be used to, the formula is mu s n. Okay, so we have all the values, just substitute into the values, you'll then get 50.1 Newton as the static friction force. Okay, so it's really simple. Okay, the physics are very short but the maths are very long, so make sure your maths are really good. I mean, rearranging all of this shouldn't be a mistake lah. You shouldn't have to make, I mean, you shouldn't do any mistakes sebab physics day ni je yang ini ni. Okay, so if you are able to do this, that's great. And okay, so that is the example number 6.